thank you everyone for joining today's Bridgewater Distinguished Speaker Series. Now, there's many ways to describe the occupation of our guest, David Sinclair: professor, inventor, innovator, company founder, best-selling author, healthcare pioneer. But he's probably best known as a tenured professor of genetics at Harvard Medical School for his research on delaying and reversing aging. And there's so many ways to access his work: 5 books, 2 documentary movies, 60 Minutes, and a raft of other media. And David's also the co-founder and co-chief editor of the scientific journal Aging. And there's so many ways that he's had an impact on this field. He's published over 200 scientific papers, co-inventor on over 50 patent and patent applications, cited over 73,000 times, co-founder of a dozen biotechnology companies in the areas of rare diseases, inflammation, vaccines, infectious diseases, diabetes, fertility, cancer, and biosecurity. And 4 of these companies have gone public. And there's so many accolades, more than 40 awards, including Australia's leading scientists under 45, a medical research medal, the Merck Prize, the NIH Director's Pioneer Award, an Officer of the Order of Australia, on Time magazine's list of 100 most influential people in the world, and the top 50 people in healthcare. Now, I know David, as we both sit on the advisory board of a biotech company, and I first met David around 6 to 7 years ago over a coffee in Boston. And what immediately struck me, beyond David's intellect and vision, is that even for an Australian, where there's a very high bar, David is incredibly approachable. And he also makes science incredibly approachable. And this is also the experience I had when I read David's book, Lifespan: Why We Age and Why We Don't Have to. And this book's been a New York Times bestseller and an international bestseller. It's been published in over 20 languages. It highlights David's work from his own lab at Harvard about the process of scientific discovery that reveals the emerging technologies and simple lifestyle changes that have been shown to help us live younger and healthier for longer. And along with his broader work, this book addresses the implications of delaying and reversing aging, including the economic, political, and philosophical implications. And so for this Distinguished Speaker Series event, we're going to have a wide-ranging discussion that's going to include David's work on reversing aging, what we as individuals can do to extend our lifespans, how we as a society will fund longer life expectancy, the actions that can be taken by policymakers to increase life expectancy, and the impact that this can have on economies. And then finally, we'll touch on some philosophical questions associated with delaying and reversing aging. Now, there's a lot in here. A lot of it's mind-blowing, so strap yourselves in and we'll get into it. If you have any questions, please drop them in the Q&A function, and we'll hit a few of these at the end of the discussion. So with that, thank you so much for joining us today, David.
Atul, thanks for having me. That was a very kind introduction.
I was thinking about the best way to start this discussion with you, and I thought, look, the best place to start would be all the way at the start. And so are you able to take us back right to the start, to the world 4 billion years ago, as you describe in Viva Primordium, the first chapter of your book, Lifespan? What was life like then? And how does that environment inform us about extending lifespans and reversing aging?
Well, the world was very harsh in those days, and life was fragile. And these early organisms needed a way to survive that adversity. And it was a competition for survival. And we are the final product, or not the final, but the current product of that battle. And early on with life, we know that one thing was necessary, and that is to be able to take in energy and turn it into new molecules that formed life. But we often forget that just as important are mechanisms to be able to survive the harsh conditions that life finds itself in. And if you cannot survive, then you're going to be outcompeted very quickly. And so we are the product of that. And there are genes in our bodies that go back billions of years that are the product of that evolution. We have survival genes in our bodies. There are a set of 7 of those genes that we work on and we link to aging back in the 1990s, called the sirtuins. And these genes, they come on when we're under adversity, just as they did 4 billion years ago. And what they do is they give us extra survival. They give us extra health. They fight diseases. and they also slow aging.
Okay, so now we'll bring it forward a little bit, turning to what everyone's first question is whenever I tell them about your work, but I'm going to frame it a little bit differently, and that is that in 1900, life expectancy in the US was 46 for males and slightly higher for females, and that's been evident in the data ever since. In 1920, life expectancy was 54. In 1950, it was 66. In the year 2000, it was 77. So over the past 100 years, life expectancy is up around 30 years. Now, according to the World Bank, in 2020, life expectancy is 79. Now, do you think that life expectancy, the age of 79, is correct in light of your work?
Well, yeah, for people who were born a while ago, yeah, this is how long the average person lives. But what these numbers are not taking into account, especially for those who are born today, are the rapid advances that are being developed and we're seeing right now across the planet in being able to slow down the aging process. So life expectancy for someone today really shouldn't be 79 or 80. It will be much greater than that. There's no question about that. I don't think anybody who's in this field of longevity research believes that that's going to be the case. And we've seen a steady line up with lifespan over the last 100 years. It doesn't show any sign of slowing down. Of course, there was the pandemic, which is not a natural lifespan decrease, nor is the opioid epidemic. What we really will see over the next 100 years is a dramatic increase in life expectancy to the point where people will expect to live to 100 playing tennis, hanging out with their great-grandkids. This is really not a question of whether this is going to happen anymore. As I hope we'll talk about today, there are such advances that we can slow down aging already. We know of medicines and molecules that are very likely to extend lifespan somewhere between 5 and 10 years, as well as we now understand how to live our lives in a way that gives us those extra decades. And so 100 years from now, people will look back at us with the same pity that we do people who grew up without antibiotics and modern medicine 100 years ago.
Yeah, so we'll definitely spend some time talking about that today in terms of, in terms of some of those pharmaceutical developments. And just to put you on the spot then, I mentioned that in 1950, US life expectancy was 66. So let's put some numbers on it. What do you think it'll be in 2050?
Well, we can talk about life expectancy of someone who's born in those years, or what about our generation? So I'm 52. Let's talk about someone like me. I think we, in my generation, can expect to, if we look after ourselves, if we do the right things, if we don't smoke, we don't overdrink, we exercise, we eat the right foods, and we don't overeat, that alone, just what I just mentioned, gives you an extra 14 years. That's a fact. But there are supplements and drugs I mentioned, and combinations thereof, and the timing of when you eat, that I believe can give you at least another 10 years on top of that. And so that, takes me to an expected lifespan of 100. And what does that mean? That means when I'm 80, 90, I can still be healthy. I can still be running around. My father, who's 82, and who has done the right things and is taking some of the same supplements that I do, he has no aches and pains, no diseases, super active, super energetic, has a better social life than me, and is actually stronger and fitter than me at age 52. And that's the life that I see most of us who have the knowledge of how to live longer can expect to have. Now, there's going to be bad luck, of course. Not everybody will be able to get there, but we want to give all of us our best chance possible. Okay,
so we started with 4 billion years ago. Let's fast forward now to say around 50 years ago, we'll call it 52 years ago, to Australia. Now, you grew up in St. Ives, which is just a few minutes up the road from where I grew up in Roseville. We have the same alma mater, the University of New South Wales. So maybe tell us a little bit about your upbringing and how you got into this field.
Sure. I was a pretty average kid. In Australia, we used to be let out and we go on bushwalks and this kind of thing. And I was lucky enough to be born into a house and stayed in a house that was on the edge of the bush. So I spent a lot of time looking at life, exploring the wilderness. We had about literally a contiguous 1,000,000 acres of forest in our backyard. And it probably went all the way to Roseville. So I grew up with a fascination for living things, and I like to understand how they work. I find them very fascinating little machines. I certainly pulled apart my fair share of insects as a kid. But I've always had a really strong passion to change the world. I had a grandmother who mostly raised me and told me that the world is a horrible place when humans do bad things. She grew up in the early 20th century, right, where things were really bad in Europe. She was Hungarian. And she said, David, you have to make the world better and show humanity that they can do better and be the best they can be. And so I grew up with that. And so I set out to try and leave the world a better place. And I've spent every day of my life doing that. And so I got a PhD in molecular biology and genetics, and I had a passion for understanding why we get sick. And instead of becoming a physician, I became a scientist because I thought I could help billions of people rather than thousands. And that's what I've been doing. And I thought the best way to improve health was to understand why we get sick in the first place.
And so maybe turning to that science and some of your more recent work, and just for everyone watching and listening, how does the science around extending lifespans and reversing aging work in a really practical way? Now, in your book, there's some beautiful illustrations that you have in there. They use the analogy of a DVD being scratched. So maybe it'd be great if you can start there, recount the DVD analogy, and talk maybe about some of the work you've done with mice, with their optic nerves. It'd be great to just understand that science in a practical way, as you do so well.
Well, I'll try to be brief because it's 25 years of research. It begins with yeast research. I moved to MIT in 1995 to work with Professor Lele, and it was a fantastic 4 years. We discovered why yeast cells get old and the genes that control that process, the sirtuins I mentioned, and that DNA breakage leads to problems in the cell, which we now believe is a major cause of aging in our bodies. If you want to just boil it down to what I think is really causing aging, it's a loss of information. I could write that down in a single equation if you wanted to. What it basically says is that in our cells, we have information and that we lose it over time, and cells and tissues and organs lose their ability to function, in essence, because those cells forget how to work. They lose their identity. And there are two ways that the cells encode their identity from birth or before that, from conception. One is in our DNA, which we hear a lot about, but the other type of information that we need just as much is what's called the epigenome, which are the control systems that tell which genes to come on in which cells at what time. And every cell has essentially the same DNA, of course, but what makes a brain cell different from a skin cell is the epigenome. Think of it as the reader of a DVD disc or the software in a computer. And I believe that aging is due to the corruption of that software. And we've worked out what causes that corruption, or in the case of the DVD or the disc, it scratches, so you cannot read the beautiful music anymore. And we understand the processes of all of that. And we can actually now drive aging in the forwards direction. In my lab, we've been making mice get 50% older, sometimes within a month, within 10 months. And they literally get older. We can now measure that by looking at chemicals that control the epigenome. One particular type is called DNA methylation. You can have a mouth swab, and I could tell you how old you are biologically. Now, that was all fine and good, that we could understand why we age and drive it forwards. But the question is, if you understand why something happens, if you can make it happen, can you take it away? And I studied and was fascinated with the work of a professor, Claude Shannon, at MIT in the 1940s. And he came up with mathematics that explained how to preserve information. And if there's noise that happens, you can actually get around that. And what he came up with was the idea of having what we now know as just having a backup copy. And the question was, in our work, is there a backup copy of youth? Is it possible to polish off those scratches on the disk or reboot the software of a computer? And we didn't know until December well, the world didn't know. We knew a few years before that, whether it was possible to safely do that. And of course, safety is an issue because if you erase the cell's identity, it'll become a tumor or just die. And we didn't know if you could wind the clock back to say age 20 instead of 70 and not cause cancer or kill the tissue. And what we've discovered, to our delight, is that cells have a mechanism to actually polish those scratches, reset the cell, and be young again without causing any issues of health. And we published this in the journal Nature in December. It was on the cover. The title on the cover was Turning Back Time. And we used this gene therapy technology to reverse aging in old mice. We put it into the old mice in their whole body. It was safe. And we chose the eye as a place to start. And we could make old eyes young again. We do this routinely in my lab now. Those eyes are blind in the old mice, and then the mice can see perfectly again after 4 weeks of treatment. And we think that this can be used not just for treating aging in humans, but also restoring eyesight caused by genetic diseases and even glaucoma, pressure in the eye, a leading cause of blindness. And so I've started a number of companies, one of which is doing clinical trials or heading towards clinical trials in 2023. We're about to start primate studies after a lot of mouse safety studies. But long story short, we've shown that there is a backup copy of youth in mammals. We know it's true for human cells. We can reprogram human skin and muscle and even brain cells. And so we're at a point now where the question is, how soon can we get this to the public as a medicine? And we're going as fast as we can and as safely as possible as well.
So I want to come back to the mouse in a moment, but before we get into that, on the science, what's the biggest area of pushback from purely from a scientific perspective that people have pushback on or people have criticism of? And of these, which of those areas of pushback do you think have merit? How are you thinking through that as well?
Yeah, I'm chuckling because almost everything we've ever put out, hundreds of papers, people always criticize. So it's what you expect as a scientist. That's how it works. But we tend to push the envelope so it gets people upset. And that's the idea. We like to do that. And so over the years, we've had pushback on everything from longevity genes controlling aging to molecules in red wine that affect longevity. And this new work, I think most people are accepting of it, actually. It's one of the first papers we've put out where people go, okay, that sounds pretty realistic. But there's this gut feeling of some people that it sounds too good to be true. There has to be a problem. Is it going to cause cancer? Is it not going to work in humans? Maybe it's easier to do in mice, but not humans. But that's natural. You know, every time something sounds too good to be true, we have to be skeptical. That's what we do. But I think the fact that we have shown here that there is a backup copy of youth means that it's going to be possible, whether it's me or someone else, it's going to be possible to truly reset the body's age, not just by 1 or 2 years, which has been done already, but by decades. And really the question is, how's that going to work? Is it going to be a gene therapy, which is what we used in the mice and we'll use in the eyes, or will it be just taking a few pills for a month and going back in time, or is it going to require stem cell therapy? And actually, the interesting thing is that now there are dozens of companies working on this, even just since December, because it's such a hot area. And literally billions of dollars have been now brought to bear in this area and will be put to work. Again, making it clear to me that it's not a question of if this is going to happen, just when.
Okay, and so let's take it now to from mice to humans. In your work, you mentioned that NAD boosters can help reprogram the optic nerves of mice, restoring sight after damage and improving the health of mice. You've also discussed how these NAD boosters can mimic exercise and improve the fitness of mice. And you've also discussed how the boosters can reset aging and take the mice back to their useful cells. Now, before getting into some of those pharmaceutical developments, what are the lifestyle changes that people can make to extend their lifespan?
Right. Well, so for those of you who have picked up a copy of my book already or will do, the book's called Lifespan. On page 304, I talk about, uh, I just list out the things that I do and my father does. So that's the cheat sheet. But if there's one thing that I would say would make the biggest difference to your long-term health, it would be this: eat less often. Okay. It's not so much what you eat that's important. Of course, eating terrible food's not going to help you, but it's more important when you eat. And by that, I mean the 20th century was based on have a farmer's breakfast, have a snack in the morning, have a lunch, have another afternoon snack, have dinner, maybe have some extra dessert, some alcohol. This has been a disaster, of course, for the developed world and increasingly so in the developing across the planet, even more so actually in poorer countries. I should update that fact. But the converse is also true, that even just sticking to what's considered what nutritionists generally regard as a healthy diet, in my view, is not as healthy as skipping at least one meal a day out of those three, and don't snack. We used to think, well, scientists and nutritionists used to think, and many of them still do, to be honest, that you want to keep the body fed all the time, stay up here with blood sugar levels so you don't ever get hungry. I would say the opposite is true. You'd rather have low glucose levels, not so much that you're starving or having malnutrition or you're distracted, but there's a beautiful intermediate zone where if your glucose levels stay low or at a lower level and don't spike during the day, you power through, you think clearly, your body functions optimally. And here's the key: you turn on the body's defenses against disease and against aging, and you stay younger for longer. It's not really a question about whether this is a theory that's correct or not. This is a fact. If you give your body times without food, it will be healthier. And I'm not just talking about preventing obesity. I'm talking about being hungry for part of the day. Now, I'm rarely hungry now because I'm pretty used to not eating until dinner. I eat one meal a day, and I do drink during the day. I'm having coffee, right? I do drink a lot, but I try not to fill up on things. I'm not super strict, by the way. If you're wondering, am I crazy? No, I'll have a dessert once in a while, and I'll have lunch if I want to. But I do try my best every day to only have one meal. And what's happening during the day and through the night is that my longevity genes are at hyperactive levels. They're being stimulated. And I can feel it in myself. I'm very different now than I was when I was eating 3 meals a day. And then my blood biochemistry, I track everything, not everything, but I track 43 things in my body, and I have done so for a decade. And I can tell you that this diet has had remarkable effects on my body. In fact, you can calculate my biological age by putting these parameters into a calculator, and it comes out that I'm still in my late 30s, early 40s at age 52. Now, does that mean that I'm necessarily going to live to 100? No, but I think it gives me a much better chance than I would have if I just ate the way nutritionists recommend.
Okay, and beyond from a diet perspective, any other things that you can speak to?
Yeah, there's a long list of things that I do. We could talk for an hour as well, but I'll try to rattle them off. Obviously, get good sleep, because you're actually the longevity genes that I work on control sleep and vice versa. Okay. So you don't want to get those out of whack. You want to move a bit. Don't sit down all day. Get a standing desk is helpful. Build up muscles. Build up the big muscles. Maintain them, especially if you're a male. You do lose a lot of muscle as you get older. So I do deadlifts. I do hip hinge exercises, lifting weights like this. I try to work out, and I'm stronger than I've ever been. So that's good. And that's important for hormone levels as well as not breaking your bones when you get older. Do move, do lose your breath at least a couple of times a week, 10 minutes at a minimum. Doesn't have to be a marathon, but do get out of breath. Being hypoxic, as it's called, is very helpful. Don't eat too much red meat. I know some people love red meat, and there's a carnivore trend. There's no evidence that I've seen in looking at populations that kind of a diet is going to make you live longer. It's more like a Mediterranean diet that ends up being the winner, with olive oil, lots of fresh vegetables, vegetables that are under stress themselves. So when you stress food, they make molecules that turn on your body's defenses. This is one of the things that I study. So those are all things. There are some more advanced things that might work, saunas, ice baths as well. The idea is to put your body into a state of perceived adversity. You do not want your body to be complacent. But the problem is with modern life that we have, everything is about being satisfied. There's enough food that you can sit around. Even our suitcases have wheels on them. We need to get out of that complacency and trick our bodies into thinking that we could die, just like those original cells did 4 billion years ago. We still have those same systems that we need to activate.
Okay, so where are we in the movie for aging research? And that's when we think of Bridgewater, our role as global macro investors, we're always trying to understand what's around the corner for economies and markets. What's around the corner from you for you in terms of where we are in terms of this research? Also, maybe touch on some of the pharmaceutical developments that are coming through. You've said previously that aging research today is where cancer research was in the 1960s, and so maybe just give a sense of where we are today, and then going forward from there.
Yeah, well, I think we've now graduated to the 1980s. Things are going so fast. They're going similar to genomics in the 2000s, and then crypto in 2010s. This is the next big thing from my vantage point, and I do have a front row seat. So what I'm telling you all is, people that have been interested in crypto, in genomics, in mobile phones are now turning to longevity as the next big thing. So big investors I'm being contacted by almost every day. Big funds being launched in the billions of dollars. I know of one that's got 6 billion, another one that's north of 10, to invest in longevity, research and development, and companies. So these are big numbers, and those are just two that I've mentioned. Also, governments have woken up to the fact that aging is now malleable. We can control it. The World Health Organization has declared old age a medical condition. And that will, if that flips and governments change the definition of aging as something that's treatable, then I would say all bets are off. Then the world will be transformed into a world that was as big as the invention of first flight and silicon chips. So the reason I say that is that right now, when we develop drugs for aging, and there are now over 100 companies working on this, it's really quite an active area. Those drugs that we develop have to be, I wouldn't say snuck onto the market, but have to go through a path of development for either rare diseases or diseases that are, of course, recognized by the FDA, such as obesity. Blindness is one. But the ultimate goal is for that drug or those drugs to then be used widely. And I think the first drug that gets on the market will be used widely. I wouldn't say off-label because that's a bad term, but I think that there will be clinical trials testing these medicines in other areas. So for instance, we have clinical trials that have been ongoing now for 2.5 years at Harvard and now at other hospitals around the country for rare diseases. And if that gets on the market, then you can bet that doctors will use that same medicine to treat try to treat many other diseases. And eventually, I think that governments will have to switch into allowing doctors to prescribe those medicines to anybody, say, over the age of 50, biologically speaking. So the other parallel path is not just these development of drugs, but also we have these tests that can tell you very precisely how old you are biologically, not how many times the Earth has gone around the sun, which is pretty, these days, not so relevant. But just for instance, we have this test that we are going to be launching, which is a mouth swab. And I can tell each of you how old you are biologically. If you've smoked and not done any exercise and you're obese, you're going to have an older age than someone who's looked after themselves more. But we can also now use that test to help get you back to be younger and to slow down the entire aging process. And that's the future. And I think the medical establishment, insurance companies, and governments will have to follow suit.
Okay, and so the money is going there. That's the first thing you laid out, that the drugs are being developed and we're now getting, I guess, more acceptance or ability for people to check their their actual age, not how many times they've gone around the sun. All of this that you're talking about, it's all a little mind-blowing. And because it's mind-blowing, or maybe the reason that it's mind-blowing is there's some really important economic implications and policy implications and ethical implications because of this. And maybe we'll turn the conversation to that now, which is the societal implications of this. And I know you've had a lot of thoughts on this, and I think what people should know is unique about David's work is that he's approached this topic in a way that uses a lot of consultation. He's consulted with some key constituents in the fields of politics, in the fields of economics, in the fields of philosophy and more. And I think that's really something unique. And so we'll turn maybe to talking about society and about systems generally. And so, look, one of the first things that sprung to my mind from this, and certainly the big thing on my mind when reading your book and in following up on your work, is that there's a huge impact on a lot of our systems. Our pension systems, our healthcare systems, our education systems, they're all set up around the notion that a certain number of people are dying before they're age 75. 95% of people are going to be dying before they're 100. And so maybe let's start there. And I'll hit on the pension system maybe, and then I'd love to turn to you and hear your thoughts on that and other systems. So, if we think about pension systems in 2020, so this is prior to the large increase we've seen in asset prices over the last year, US public pension funds were on average around 72% funded, meaning around 28% underfunded. And there's a large range around that. Some are underfunded by large degrees, some are fully funded. Now, the big deal variables that are going to be impacting pension liabilities are the number of participants. More participants means bigger liabilities, the average benefit level, larger benefits, bigger liabilities, and of course the discount rate. But life expectancy is also a really important input. Longer life expectancy is also going to mean bigger liabilities. Now, there's been some work done by the Center for Retirement Research at Boston College, and that's shown that if beneficiaries live one extra year, liabilities on average increase by an additional 3.5%, which is a pretty big shift. Now, of course, there's going to be a range around that. The good news is that a lot of plans are keeping up to date with the latest life expectancy assumptions, especially so the larger plans, but it's still a big deal. And there's even more of a need for an adequate pool of post-retirement assets, and that's at the plan level. It also impacts individuals. And in addition to that, the size of the post-retirement asset pool, there's also big implications for asset allocation that these plans have. And so we always say it's important to be prepared for the wide range of outcomes that could impact economies and markets, but it seems even more important when the time frame over which these outcomes can transpire is so long. And so turning to a more direct linkage, such as the healthcare system, and I know you've got a lot of thoughts on the pension system, but also the healthcare system. Look, David, healthcare systems in certain parts of the world are already stretched in terms of being able to handle patient loads. Wouldn't increasing everyone's lifespan place further pressure on those systems, especially given we've already seen life expectancy increase, but the proportion of life in good health is remaining broadly constant? What are your thoughts there?
Yeah, well, we need to change our view of what medicine is all about. First of all, we've been approaching medicine system by system, organ by organ, disease by disease. And while we've been very good, for example, keeping the heart healthy, the brain still ages. And so what we've ended up is really a nightmare for humanity, where people spend sometimes the last 10 years of life in a decrepit state with dementia and their heart still beating. That's the wrong way to approach medicine, in my view. What we need to do is to understand why all of those organs are decaying. And I believe we now understand that. And then we have the ability now to keep them all healthy. So when you think of what you call lifespan extension, it really should be talking about keeping people younger and healthier for longer, not just one part of their body, but all parts of their body. The other way to think of it also is in terms of ethics. How many billions of dollars does the US put into medical research to, let's say, cure cancer? Well, nobody's against curing cancer, but even if we cured all cancer today, people would only live another 2.3 years, and it wouldn't be a particularly healthy life anyway, because all these other things are breaking down. Mm. So the point of my argument is that we're going to live longer, but we're going to be in a state of youthfulness and productivity. So people who, you might say, okay, someone who's in their 90s is going to be a burden on society. It's the opposite. They can still run companies. They can be community members that are productive. They can help raise the grandkids instead of being in a nursing home and being cared for and costing a lot of money. Now, does it mean that everyone can afford to retire at 67? No. We will have to change that in the same way that we had to change things when people started living beyond 50. But it's still a much better world, because if you do the calculations, and I have with a couple of good colleagues over in London, both economists, the actual savings to the US economy, actually it's in terms of value to the economy. If you extend healthy life just by 2.6 years, which is really easy to do, then that gives you in the US an extra $86 trillion to the economy over the ensuing 30 years. If you extend lifespan by 10 years, which I think is doable as well, now we're talking about $365 trillion of value to the economy that would otherwise just be lost on healthcare, which is increasingly costly because we're approaching it the wrong way, using what I call whack-a-mole medicine. So ultimately, this is going to lead to a much better world where people are healthier, lead better lives, and would not want to go back to the times when you can get sick in your 70s and die in your 80s or 90s and be a burden on your family. What's going to have to change? Well, people will have to work for longer. But if you are living longer, and you can even stretch out the period of fertility, we believe, then people have many more options in life. They can have multiple careers. And I even am in favor of what I call the skill batical, so that once you're 40 or 50 and you've done enough busting up of roads or doing what career you ended up being in that you don't like, you have a chance to start again. All to say that working longer shouldn't be a burden, and people should have a chance to find their passion and do what they love, at least for some part of their life.
Okay, so we've tackled the pension and healthcare systems. Next is education. Now, Bridgewater, we're on a mission of continual learning and understanding economies and markets, and we've, you and I have discussed that previously. We represent that in what we call our research circle. It has no start and no finish, but we recognize that most of the world isn't like this. You recognize most of the world isn't like this, and actually it's the exact opposite. And so most people get educated from the age of, call it 3 or 4, to the age of 23 or 24. And so when I think about the idea that future generations are going to be living to 150 or longer, it seems a little nuts to condense all of that education into 15% of your life and the first 15% of that. So do you have any thoughts about the education system? And that's both coming as someone who works for an educational institution, but also as a parent, in terms of how we can rethink education in this context?
Well, definitely, we're moving towards that kind of a world now, where it's much easier to get an education in your 40s and 50s through online learning. But still, there isn't enough support for citizens to be able to do that, right? Most people in their 40s still have kids at home. They have to look after, pay for a mortgage. I think that with this cost savings of improved health, that money should be poured back into allowing people to have education when they need it, and perhaps paying some of their bills to offset that time when they're not going to be working, and even part-time work. At least you could give them some time off to do that. That's going to be a much better world for everybody, because retraining is so critical these days, that your jobs are changing so quickly. Most of us go through 5, probably eventually 15 different types of jobs. That kind of a world, I think, is accelerating. The pandemic helped. Speaking about kids, first of all, having people around for longer, I think, is going to be very helpful for kids. More and more of us need to step up and be mentors to the younger generation, who, by the way, I think for the first time that I'm seeing in history, that they have such maturity and worldliness about them that they really do care about learning more than I think even the previous generation did. I've tweeted out once something to the effect of, for the first half of your life, find a great mentor, and for the second half of your life, be one. And I really believe that. And I've reached a point in my life where I think I'm halfway, hopefully. And I'm turning to be a mentor, essentially. Mostly what I do is mentorship now. That's a world that only gets better as people live longer. And imagine the wisdom you could get from somebody who's 150 years old. They would have the memory and all the knowledge going back, even to the 1800s, if it was somebody around today. And I think that we could avoid a lot of the mistakes of the past. Now, there's an argument that, are people going to change their views, or are they going to stay conservative? Somebody from the 1800s might have racist views, but I think that that's narrow-minded thinking. If the mind stays young, which we believe we can achieve, then you can change your views. I mean, how many of us are now at my age listening to young people's music? We're able to cope with new technology. Those of us who have grown up in the 1980s and 90s and 2000s have had to learn to adapt very rapidly, and I think are very capable of change as long as our minds stay young.
Yeah, there's a few threads in there that I would like to pull on as we move through this conversation. Just one worry I do have, though, and part of this comes out of reading the work on this, and also part of it just comes out of the world that we're in, which is a worry I have is whether this technology will be available to everyone. Now, we already have immense wealth inequality, in part because our institutions, some of the policies over the last 40 years have led to that. The pro-corporate, pro-capitalist policies have contributed to now what is the greatest degree of wealth inequality that we've seen since the 1930s. That's contributing to populism, rising levels of conflict within countries, between countries. And so my question to you is, will the availability of this type of technology create another form of inequality? I'm just going to call it age inequality, where those with the resources can live a lot longer than those that don't have the resources will live maybe on these numbers 20, 30, 40% less. Is that a concern?
Yeah, it's definitely a concern. I'm passionate about democratizing the tests and the advice and educating everybody. It's the reason I educate so much. It's the reason if you Google me, you see me all over the place. I'm trying to get the word out that small changes can greatly affect your future health. I think ultimately these drugs can be made cheaply. There are some medicines that I'm co-developing that could cost 2 cents a day that would treat obesity and extend lifespan, I think, quite dramatically. But initially, all technologies start out more expensive. There's no question about it. To develop a drug, the government makes us spend hundreds of millions of dollars, sometimes billions. You can't do that for free, and not pay back investors. So the system is set up for drugs to initially be expensive. It's just capitalism, but that's the only way that it works right now. That said, my patents will expire, other patents will expire, and these drugs won't always be expensive. And I also am working very hard to turn expensive medicines, such as gene therapies, into cheap pills. So in my lab at Harvard, we're actively looking for ways to, instead of using gene therapy in the eye, to put an eye drop with some chemicals that would cost a few cents. That is going to be doable, I'm certain. A drug such as metformin, which is the world's leading drug for type 2 diabetes, for high blood sugar, also only costs a few cents per pill. And that's available globally. It's on the list of the World Health Organization's list of essential medicines for humanity. That drug, there's a lot of evidence actually, that it actually also slows down aging. So I already believe that we have a drug that would extend lifespan, slows down aging. I take it myself every day. And it's available to almost everybody on the planet for only a few cents a day. And by the way, in most countries, it's available over the counter like an aspirin. It's just in Europe and in the US, it's classified as a drug and needs a prescription.
Okay, so you've brought up the topic of policy and policymakers. So maybe we'll turn the next piece of the conversation to that. And so one of the biggest challenges facing nations around the world is declining growth rates. And so developed world real growth rates, so real growth ex of inflation, it's around 3.5% in the 1970s. It's progressively declined to 2.7% in the 80s, 2.5% in the 90s, and just under 2% for the past 2 decades. And Moreover, potential growth slower, well under 2% for the US and other parts of the world, of the developed world, over the next decade. So it's slowing. And if we've got potential growth, which is around half the rate of real growth that was in the 1970s, part of the reason behind that is declining working age population, and that contributes to lower productivity. Now, that's just one input. There's a lot of inputs that go into potential growth, such as investment in technology, some of which you're talking about, some investment into the workforce flexibility. There's some of the offsets. But an increase in working age population growth driven by the working age component of that equation, it could be a huge productivity enhancer over the next few years. And I know you've done some thinking about that. You did mention some of the work you'd done with some economists earlier, and I know that was published recently, and anyone can pick that up. In July this year, you co-authored the paper in Nature Aging entitled "The Economic Value of Targeting Aging." And that paper addressed the economic value of increases in life expectancy. And so your analysis showed, and you'd given this stat earlier, but increasing life expectancy by around 1 year adds $38 trillion to the US economy. And so if you're able to maybe talk through that in a little bit more detail in terms of what policymakers can concretely do, what your hope is there, and maybe even touch on some of the changes that can be made to systems.
Yeah, well, it's really easy. In the US, the FDA would classify aging as a medical condition, and then doctors wouldn't feel guilty or at risk prescribing a medicine like metformin to their patients before they get type 2 diabetes. And it's been shown by looking at tens of thousands of people that metformin reduces the rates of cancer, heart disease, Alzheimer's, frailty, and of course, type 2 diabetes. This drug is available. So if the government changed that policy, FDA, overnight, things would change. Not only would people have access to this drug, and it would probably be given to millions of people the next day. On top of that, there would be huge amount or even more investment into aging research and development of other drugs, because now there's a clear path to the selling of drugs to hundreds of millions of people, even just in the US, but globally, even upwards of $1 billion. These could be the drugs that are the most successful in the 21st century. I think this is going to happen. It's just really a question of, is it in 5 years or is it in 10? I know there's going to be a lot of pressure on governments with these big investment groups who are very powerful to change that. So when that happens, this industry of treating aging is going to be one of the largest industries on the planet, and it will drive productivity across the globe as people don't have to wind down in their 50s and 60s physically. And in fact, as I've shown and my father has shown, people just get better with age.
Yeah, and so maybe picking up on that, then you that same paper talks about the increasing life expectancy by 10 years being worth 365 trillion. So there's a non-linearity to it, which raises some interesting findings. And it sounds like a really powerful additional dynamic is at work, which is if you're slow aging, it leads to an aggregate population that on average is older and larger, but that creates a virtuous cycle where society slows aging, they demand a further slowing in aging, and it also leads to a society that ages a lot better. So there's huge health improvements. That all sounds like the topic of another book. And I know you've kind of hinted at it in some of your tweets, so I'm just going to put you on the spot now and kind of ask you what have you, in terms of another book coming, is there another book coming, and what topics could we look forward to in that? And then, and following that I've got a lot of philosophical questions, which I have and which people have brought up on the Q&A. But before we get into the philosophical questions, what's next?
Well, I actually have 2, maybe 3 books that'll be coming out one after another. The one that I'm writing is now titled Survival, and it's about the technological treadmill that we've found ourselves on over the last 6 million years, since our ancestors first picked up a stick and used it as a tool. And there are 4 traits that make up humanity's ability to change the world and shape it. We're storytellers, we're explorers, we are tool makers, and we're time travelers. And these traits are different than any other animal on the planet. And those traits have gotten us to a point where we have a world that in many ways is so artificial that none of us can survive in the wild anymore. And there are good parts about it, but there's a lot of bad things about the world we live in. Environmental degradation is just one of them. There's problems with social media, there's problems with sleep, there's problems with our food. There's a long list. So the first thing that I'm addressing in the book is how did we get here? The second is, what do we do now that we're in this situation where we need even more technology to get us out of the problems that we've already created? And then the third is, what can we do as individuals to live better lives? And what does the future look like? Part 4 is, can we ever get off this treadmill? Or is a species that picks up a stick and starts using these advanced tools and grows a big brain because they're trying to outmaneuver other members of their clan? Are those animals, whether they're on another planet somewhere in the universe or just us, can we ever get off the technological treadmill? And I think the answer is no. Once you're on this treadmill, you can never get off, unless you want to go extinct, but we do not want that to happen anytime soon. So the solutions that I have, I'll lay out, are today, let's use the 4 traits that have gotten us here to get us out of these problems that we've created.
Okay, and so it sounds like a future worth living, and certainly a more positive tone to it. But there are philosophical and ethical dilemmas this creates, and so I'd love to have your view on it, which is, and just putting it bluntly, is it a good thing to have Supreme Court judges with lifetime appointments that live until they're 200? Is it a good thing to have politicians that are in power for 100 years? So how have you thought through some of those philosophical or ethical questions around a lot of this work?
Yeah, well, laws can be changed, right? If we find that as a society that we can't put up with 200-year-old politicians, you can change the laws. This is not a reason not to make people healthier. Why don't we just stop all medical research if we're worried about people living longer? To me, it's a silly argument to say we shouldn't work on aging, but we should pour billions of dollars into addressing what aging causes to our bodies. Let's face it, these diseases that kill us, 90% of that is really caused by aging itself. We're just sticking Band-Aids on at the end. But yeah, I think that there are conservative politicians, not conservative, but people who have opinions that don't change. And that's one of the downsides. I'm optimistic that if people stay young and you can make their brains go back to being 20 again, they can change. Not everybody can, I don't think, but most of us who remain young at heart do change. My views change all the time, and my interests. But ultimately, I would say that we should adapt the laws to those changes that occur when we extend healthy life. Not that we should worry about doing so before it even happens.
Okay, and so we've spoken a lot today about the science, the implications for our economy, institutional systems, for our own health. Bring it back to us as individuals, away from society. Now, in that paper on nature aging, you made some assumptions around how individuals make choices about consumption, hours worked, and leisure based on wage rates, interest rates, retirement age, and knowledge of remaining life expectancy. Now, they're all really hard things to quantify, but you've managed to do it. When I read your book and your research, it really felt like I'd been given a superpower to be able to stretch time or a piece of knowledge that the world didn't have. And it opened up a whole world of possibilities, discovering not possibly, but probabilistically, I could live to 120, which is kind of 30 to 50% longer than what we've all been brought up and conditioned to think is possible. And so that discovery, and just, for myself and other individuals I know, it's meant you can learn new languages, you can relearn musical instruments, you can research areas you've always wanted to understand. It means you sometimes have a different approach to your family and your children, just to name a few. It also changed my perspective on work. And I'd like to talk a little bit about, just to close on what your goal is around this, and connecting it a little bit to work and a little bit to family, which is I'd always planned to work forever, but it underscores the importance of doing something you love. I've spoken to friends about this, and some have even floated the idea of starting a second career, retiring at 65 and starting over in a new field. Now, you've previously discussed your father having turned back the clock and now having greater vitality than his friends. And you just mentioned earlier that he has a better social life than you and potentially starting a second career. And so I guess that's all to say that I found this work really life-changing. And is that the goal of your work? What is the goal of your work if it's not that?
Well, the goal of my work is to please my grandmother. But that is going to hopefully be achieved by changing the way people can live their lives and view their own lives. I see a much better future for humanity, and I want to create that for everybody if I can. My father is a really good example. I call him the beacon of hope because he embraces the science. I'm not experimenting on my dad. He's a scientist himself, so he can make his own big decisions. So he's done all the right physical things. He's taken the same supplements that I do. And he retired at 67, thinking that was the end of it. And he was going to die 10 years later and not live a very happy, healthy life in his 70s. He's now 82. He's literally never felt better. He's never been stronger. It's quite an amazing thing to watch. He's happy. He's out every night. And he started a new career when he was, I think, 78. And here's what changes in your view when you realize that you're not going to get sick like the rest of the population. He's now looking forward to coming back to traveling Africa with me when the pandemic dies down. World travel, you can do really anything. And I think most 82-year-olds would be saying, well, if they're not already in the grave, which is where most men are at that age, they'd be saying, well, I'm too tired. I can't do this. Can't leave my house. He's looking forward to the next 10 years or more of what he's going to do. And that's a big change from when he was 67, thinking that by that age, he probably would be in a nursing home.
Okay, that's as good a goal as any to have. And I'm sure there's multiple goals you can have through this work as well. I'm going to turn to a few of the questions out of the Q&A. And so we're at the formal end of time, but I'm going to continue and going to Q&A if you've got a few extra minutes, David. Sure. And so there's a lot of questions in here, some of which we've hit during our back and forth. But one of the things that's coming up is the idea of what death looks like. So if you have people living to 100 and healthy, running companies at 90, as you said earlier, what does death look like? What are its causes? Is it similar to today where you have a slow decline in the last, call it 10 years? Or is the total length of healthy life longer? What does it look like?
Right. Well, so first of all, at a population level, it looks like we've squared the mortality curve, which means now it's a lot of people die early in the 70s and 80s, and there's a tail. We want to square that. So not everybody, but most people get to live to, let's say 110, and then bang, you hit a wall and you don't live more than another 3 months after that age. That would be a goal. We're never going to live forever. But what we know from the animal studies and even looking at people who live over 100 is that the longer you live, the faster you die and the cheaper it is. And in fact, the cheapest people for healthcare are people that live over 100 because they die quickly, because they become frail and something breaks, the kidneys fail, heart fails, and they're gone. As opposed to if you get cancer in your 50s, 60s, 70s, then you can go on for another 10 years and it's very expensive and painful and traumatic. So that's the goal, is to get us into a life that's enjoyable, vibrant, productive, and die relatively quickly whenever that time must come.
Okay. And there's a number of questions here as well about the sustainability of this. So if we've got a world in which people are living a lot longer, obviously the size of the global population is already to some degree causing damage to the planet. And so there's questions around the idea of sustainability. What are your thoughts with regards to the sustainability of all this, of people living for longer, of global population booming and And how does that, where do you think that would peak out? Just I'd be interested in your views on how many billions of people it peaks out at, and any thoughts you have around the sustainability of that.
Right. Well, the first thing to say is when somebody declares they've cured childhood leukemia, people don't start screaming that we're going to have population increase. So, saving lives is saving lives, right? So there's that morality. The other is that it's calculated that we're topping out in world population and actually we'll start declining over the next decade. We're already declining in the US and across Europe, Japan, of course, if it wasn't for immigration. And so we're at replacement levels. And by slowing down aging, we're not going to be overpopulated. You can calculate that. As much as it might feel like we're going to be overpopulated, it's not going to happen. The other thing is, even with the 10 billion that we're going to have steady state or decline with, we do need to do something about the environment. There's no question that we're placing a huge untenable burden on the environment. But what I am passionate about is that by saving ourselves, we can also save the world. And the money that doesn't go into caring for each of us for the last decade of life can be put towards research and development and programs that will save the environment and make the world a less polluted, better place for not just us, but all the animals and plants that live here as well.
Okay, and maybe we'll close it out with this question, just mindful of time, which is you mentioned being able to reprogram a cell based on a backup. Can you reprogram a cell based on new instructions, not previously present? As in, can we? And I'm just going to ask in the simplest way possible. Can we kind of create superhuman type characteristics out of all of this? How far can you go with this?
We can go as far as we choose to. There's no limit to innovation in humanity. I mean, right now I could go to my lab and create a stem cell. You can don't judge me. I'm just saying technologically, we've got human embryonic stem cells. I could make it impossible for that cell to have a lot of DNA damage. I could turn it into a sperm. I could turn it into an egg. I could fertilize that. I could implant that into a woman, eventually an artificial womb. I could make humans that never get cancer, essentially never get cancer. I could do the same for heart disease. I could probably do that for Alzheimer's as well. So if we want to, we have the technology today to make people much healthier for longer, but we don't do that because we don't agree that the genome should be edited. But my point is that we're only held back by our morality, not by the technology. I think that we now have the technology to greatly change the age and the survival of adults. They can choose to dial up their age. I was just at a conference where a number of the people at the conference, like dozens of them, have had their age reversed already. That clock that you can measure, either in the blood or in the mouth, can go back 2.3, 2.5 years, sometimes 5 years with one treatment. These are often combinations of drugs that take the age back. And some people there, after the last year, are more than 10 years younger. And I know of a doctor who had an unambiguous test that sent him back 18 years. So it's really an interesting time what happens when people start going back that much. I don't know if we're ever going to approach immortality, but if you go back in age 1 year every year, what happens? You don't get old.
Yeah.
So yeah, it's a really interesting time. It's as interesting as the invention of flight, of antibiotics, Silicon Valley. And so it's quite a stunning thing for me to be at the center of a lot of this, to see it happening at such a quick pace. And I'm just here to try and bring the rest of the world along with me.
Yeah, well, David, your work is it's incredible. As I said, it's been life-changing for me, for a lot of people I know. It's very thought-provoking, and I think what's great is your the limits of your imagination are well, there's no limits to your imagination, and at the moment, no real limits as to what you can do scientifically, which is fantastic. And what I think is great is that you not only think about what to do scientifically, but also think about the impact on our systems. You think about things from an ethical perspective as well. And so thank you so much for taking the time to join us here today. I'd encourage everyone to pick up a copy of Lifespan: Why We Age and Why We Don't Have to. You can pick up a copy of that Nature Aging journal article, which I mentioned as well, and follow David on all the various means which people can follow you on Twitter and otherwise. I know I do. Thank you so much, David, for joining us here today. It's been really impactful, and I'm looking forward to what's next over the next year, and by the sounds of it, many years beyond that.
Thanks, Atul. Well, I have a website if people are interested in signing up for this test that we'll be bringing out. It's at drsinclair.com. Spell out the word doctor, DOCTOR, Sinclair. So there's that if you're interested. And yeah, social media, I'm pretty active with education, new papers that come out, thoughts, and also trying to be a bit like Ray and putting out some of the thoughts that I've had and wisdom that I've learned over the years.
Thank you. And thanks everyone for joining. And David, we'll look forward to connecting again soon.
Thanks for having me. It's been great.
Thank you.